Hey everyone, here's another example from section 3.3. In this example, they want us to find the derivative of the function y equals x plus 4 times x squared minus 4x plus 16 all over x cubed. And it looks kind of intimidating because it looks like it's going to be a pretty long problem. The first thing I would do though before I start the problem is if I go ahead and distribute on the top, then I can simplify this because I'm only going to use the quotient rule then. So I'm going to go ahead and start by distributing on the top. So x times x squared is x cubed. X times negative 4x is negative 4x squared. X times 16 is 16x. And then, let's see here, we'll go back to this 4 times x squared, which is plus 4x squared. 4 times the negative x, which is negative 16x. And then 4 times 16, which is going to be, what, 64? And that's all over x cubed. Now I'm going to go through and simplify that just a little bit more. I can cancel the 16x and the negative 16x. I can cancel the negative 4x squared and the 4x squared. And I'm just left with x cubed plus 64. So let's write that, x cubed plus 64 over x cubed. So you can see that simplifies it a lot. So now let's go and find the derivative of y with respect to x of this function, which is x cubed plus 64 all over x cubed. Now we have to remember that the quotient rule states, and I'm going to write this out here, the quotient rule states that if I have f of x over g of x, and I want to take the derivative of that, that's going to be g of x times f prime of x. I'm running out of a little room, so I'll slide this over just a little. Minus f of x, and then times g prime of x all over g of x squared. And then I'm going to start using this formula over here. So I'm taking dy of this here. That's going to equal, so we'll start with g of x. So I need to take x cubed and write that here. So x cubed times the derivative of this. Well, the derivative of 64 is 0. So the derivative of x cubed plus 64 is just going to be what the derivative of x cubed is, which is 3x squared. I bring the 3 out front, drop it by 1, so times 3x squared. Minus f of x, which is the top function, so that's going to be x cubed plus 64. I'll put that in parentheses. And then obviously the derivative of g is going to be, if it's x cubed, it's going to be times 3x squared. And that's all got to be over g of x, which is x cubed squared. So x cubed squared. So I can simplify that just a little bit, and that's going to give us 3x to the 5th. And then if I distribute here, that should give us, let's see, yeah, let's distribute that. That'll give us 3, so minus 3x to the 5th, right? 3x squared times x cubed is 3x to the 5th, plus 64, well, not 64, sorry, 64 times 3, which would be 192 x squared all over x to the 6th, which then I can reduce that now to 3x to the 5th. If I distribute here, that's minus 3x to the 5th, minus 192 x squared all over x to the 6th, which then when I can cancel here, and that's going to leave us with negative 192 x squared over x to the 6th. And obviously you can see the x squared and the x to the 6th can cancel, which is going to leave us with a negative 192 over x to the 4th. And that's the answer. So the derivative of this whole function here is just negative 192 over x to the 4th. And we had to use the quotient rule to get there.